All right, so moving down a little bit further on this screen, there are some other options that I can change here to adjust the section below that can help me really kind of fine tune and configure the tree a little bit more. First, I can change this all-in threshold here to that. You see this box here, that all-in threshold is 67% of the initial effective stack. What that really just says is that if any of the bet sizes that we entered would force one of the players to have put in greater than 2/3 or 67% of their initial effective stack, they're just going to change that bet size to an all-in instead. It's a way to help simplify the game a little bit more. It also lets us not end up in awkward scenarios where maybe we would normally be betting a certain pot size, but it would leave us with 1/10 of a pot size bet left after that. We would just rather go all in because that's what would actually happen in gameplay. This next box, add all in only if less than, right now I have it set as 300% pot. If I click on any of these add all in buttons, this allows me to kind of give a conditional here. It's useful to kind of add conditionals to each of these different options that I have here, and only give an all-in option here if we end up getting into a scenario where that all-in would be less than a certain amount. So maybe I want to add all-ins, but I don't want to go all in for 20x pot, right? I only want to be going all in when the SPR gets down to a different manageable level. So it's useful when we can check these boxes above to add an all in, but not necessarily reflect it for very, very deep scenarios. An example of this might be like if you're in a flop spot and you're c-betting, you don't want an all in option there. But if you c-bet and get raised and it's back on you to 3-bet, then maybe you do want an all in option there depending on stack sizes. The next one here, minimum bet size in chips, it's going to let you set the minimum bet size that you have to enter. This tends to not be relevant on a lot of trees, but there are some times where, especially when some of these percentages are fairly low in relation to the overall pot, and some of these percentages might be lower than one big blind, you want to actually set that minimum bet size to just kind of ensure that you can't actually be betting something that's an illegal bet. The maximum spread here is a setting for spread limit games, so it might not be relevant for a lot of you, but it limits the maximum single bet or raise to that selected amount of chips here. There's also a couple conditional options that you have here. So you can use a single bet or raise size if there was a raise before. So it's particularly useful here for simplifying trees. If your bet and your raise, instead of having 3 different raise sizes, maybe you only want to have 1 raise size back. So you can check this box here and remove the redundant bet sizes here if they're within that certain threshold. To be honest, I'm not sure why you'd actually want to have this many options, that you'd have so many redundant bet sizes. I suppose for some bet sizing analyses, you can run sims with a lot of different options to understand, really the whole bet sizing threshold. But for the purpose of what most people are doing, you should really only have like 1 or a small number of options within your tree construction anyway. If you do use multiple options, space them out effectively where you really wouldn't have to necessarily merge options here. And that's kind of this box right here, this remove redundant bet sizes if they're within X% of each other, this merging option here. There's other spots here where we can force options here. So suppose we want to be in scenarios where we want to look at donks, right? Or we want to force a certain player to bet, right? So, the example that we talked about in the first module of maybe locking a player who's going to be c-betting all of range. We want to force an out-of-position player to bet or force an in-position player to bet after a check. We can actually do so, and it's really good to simplify that tree build to see a response against that bet 100 strategy. We'll get into a specific example of that later in the course, but sometimes we play against people who continuation bet way too much. Actually happens with a lot of live pros or laggy players, and this is a really good option to kind of build a model around that. Finally, we can add in some options to cap the betting. And, I don't use this really typically. I don't play in games that cap betting for whatever reason. But and I know some of these options were added in for limit purposes. But you can see this in the checkbox below. And, there's also there for spread limit varieties that can be played in certain portions, particularly in the Pacific Northwest in the U.S. So there's some options here that you can, kind of add some betting caps to the game tree. There's options here around rake and ICM. So by default, Pio won't account for rake, but As we've kind of introduced in the first module, rake can play a factor in changing equilibrium strategies, particularly in some of the lower stake games where a rake is a larger percentage of overall effective stacks. You can account for rake within the software to take this into consideration in the calculator. I think it's actually a cool test that you can employ a few trees with rake and a few trees without rake and notice the difference in the outputs. And again, you'll see that if you're playing a 1-2 game and you're playing a situation where, maybe the casino is taking, $5, $6 or out of a 1-2 pot, that's the house is taking 10% of the pot as a payment of rake until it reaches that $6, and that can actually be fairly significant in overall calculations. So if you do want to include rake, you would just click this checkbox and hit change, and it's going to give you a separate window that would pop up, and you can define that rake. So in that scenario there, I might say that in a casino, the rake is 10% of the pot with a cap of a certain number of chips. The thing to note here is your chips is not the big blinds. It's whatever unit that you used for this example up here of starting pot. So within my specific example here, I'm saying that a big blind is worth 10. So in this case here, I would say that if my cap was 6 big blinds, I would use 60 chips and I would hit OK. And now it's going to include rake with that structure where it's going to take 10% of the pot up to 6 big blinds. Make sure that you're consistent with the units on chips there, because again, that can be significant at the lower limits. At the higher limits, rake tends to be a smaller percentage of the overall effective stacks online, so it tends to be somewhat negligible. And live, once you get to 5-10, a lot of those limits play timed rake games, which, again, you don't have to include rake there because you're paying rake by the time, not at the individual hand, and rake is not going to impact your in-hand ranges. You can also account for ICM, so independent chip model, within your calculations. And just as rake affects game situations by changing the value of the pot, ICM can impact it in tournament scenarios. Now, this isn't a tourney course, and I'm not going to go into the details of what ICM is, but the idea is that the chips are valued differently at different parts of the tournament. Unlike cash games, each individual chip is not worth the same amount in terms of dollars, because winning all the chips or getting first in a tournament does not translate to you earning all of the money in the prize pool. Which makes sense, right? There's prizes, and all those prizes tend to be top heavy. So the first place player might make 10 to 12 times what the ninth place player would normally make, and there's a lot more value to finish higher than it is to finish lower. And as a result, certain plays might be positive EV in a chip EV scenario. So if we're playing a cash game, a certain play might be positive expectation, but it's not positive expectation when you translate those chips into the actual dollars won in the prize pool, which, it's an area where top tournament players are absolutely still learning more, and there's a lot to be learned in this space. But ICM is a model that's fairly popular to quantify the value of chips in terms of dollars for tournaments. So what ICM does is it takes into account payout structure and stack sizes. So if I want to include that here, I can click on this ICM settings, and it's going to, again, open up another window, which I'll bring over. And I can enter in the payout structure and then stack sizes for each of those individual players. Now, PIO lets you account for 18 positions when running ICM calculations, which is really great for a sit and go or the final 2 tables of a multi-table tournament, but not necessarily as helpful for things like bubble play, where ICM pressures are also at somewhat high points. Within this box, you would just enter your payout structure in terms of dollars, and then the stack sizes of up to 18 players in terms of the same units you used for the stack sizes over here on the screen. And the output's then going to use that ICM model to account for those values when they're ultimately calculating for expectation. We're getting close to the end of this tree, of this screen here. So bear with me for a few more minutes here. We're going to first look through this scripting section. So you can add lines or remove lines, which these are some free text areas. It's helpful when you want to customize the tree in certain spots. Again, you can use the visual editor here. So clicking the visual editor is going to take you back to the same visual editor, and you can remove lines, you can add lines. So let's say I wanted to remove this check option. I might just remove the selected line, and now going back to the root, I only have the option to bet, right? It's a good thing if I want to just force a bet in that scenario there. And then I can, when I'm done, I can actually save and close that there. The other thing I can actually do is I can just use the text here, which again, it's pretty simple syntax, but you do have to be somewhat comfortable with the syntax of PO. But if you do feel comfortable updating this via text, you could just do so right here within these free text files. Now, there's this big window here in the middle, and for as good as the PO software is, and I love PO, I think it's an absolutely outstanding tool. I always got to chuckle at the size of this middle window, right? There's so much information here jammed into the left-hand side of the screen, and this middle is this huge white space box. A lot of times we end up building trees that are the same trees over and over again, and these take a long time sometimes to create. So what we can do when we are comfortable with a tree, we can actually hit save current parameters, and again, it's gonna, within PO, and if I kind of click back into the PO folder, there's a lot of different folders here. One of them is a tree building folder, and I can save that configuration, and it's gonna save just as a text file within the tree building folder. The tree building folder is the text files that you actually have within there, and I'll just open up this. This is that PO scripting language, and this is how PO, the viewer itself, communicates with the solver. So if you're familiar with the scripting language, you can create these yourself if you really wanted to, but a lot of times it's just easier to create this visually and then save those current parameters there. It lets me save whatever I did on the left-hand side of the screen, but then I can also click any of these that I have here within this window and load any parameters. Be careful on clicking on any of these if you haven't saved what you already have, because you can see here, if I just click on one of these, it's going to change everything that I have on the left-hand side of the screen. And that's a problem if I haven't saved what I already have. And I really ultimately lose what I have here too. So, again, that's going to be a problem. So make sure you're careful about not clicking on that. The other cool functionality here is, one thing I can do is if I want to click this box here, change only betting structure when loading configuration. Now I can actually, when I click any of these, it's going to keep the ranges and board and starting pots all the same, but change only the functionality below, or change only the configuration below, which is, again, a really cool option here too. So moving to the bottom here, when we're actually done with the tree, we can actually build it. So let's say we get to a point where we're happy with everything, and again, I'll open up my example here, but we get to a point where we're really happy with everything. What we're going to do is we click build tree, and we click this build button, and it's going to give me this option. It's going to dispose of my current tree. That's okay. We click okay, and you'll see here on the right side of the screen what's going to happen after it officially builds. It's going to take a little bit for the solver to actually build out the game tree. And what the solver is doing here when I do this is it is actually building out the individual game nodes of the tree. And when it's done, you're going to see this option pop up that says build tree okay. And it's if it's successful, you're going to see it in that text log box here on the right hand side of the screen. Before you build it, you can actually estimate the size of the tree, which is particularly helpful if you're worried about your RAM. So some trees require a lot of memory to solve, and particularly if you want more bet sizes on earlier streets, it's going to require a lot more memory. And if your device doesn't have that much memory, you may want to actually make some additional choices in tree design to be able to do so. So by estimating tree size, it's going to pop up this window that's going to list, how much memory that you actually have on your computer, how much physical memory that the PC can parse out for a solve, and then the estimated tree sizes for both of the PO algorithms. There's kind of PO has a couple different algorithms that it can use to solve down the tree, and it's going to choose the best option for your PC. But you can kind of see how much each of those algorithms would take up in terms of memory size. You can choose which algorithm you want. So I always end up with this automatic selection, and the automatic selection is going to default to this PO CFR algorithm. But there's also this is the updated algorithm. The updated algorithm, it's more volatile. You'll see it jump around a little bit more. It also uses more RAM, but it's much faster, and it's actually better at lower exploitability levels. The other option is the original algorithm, which is not as fast as the CFR, but it's the process of getting to a solution is much smoother, and it uses less RAM. But it doesn't necessarily do very well when you get to values of around 0. So I just tend to use the auto selection here. But when you're ultimately happy with everything, you would click Go, and the solver would just run until the accuracy settings conditions are met, which we'll talk about in a second. You can click the Stop button if it's already running, which will stop the tree wherever it is in the calculation. And finally, there's a Calculate Results button, which will display the current level of exploitability at the bottom of the middle of the screen. So, if it's running, I can actually see. Well, actually, it's not necessarily running here, but this is based off of the start of the tree. It can show, how exploitable we are at, any given point of the tree. And obviously, this one is not necessarily solved down. If I load out the tree itself here, and I have my new tree that I loaded, and now I can see that this tree I've already solved is exploitable for less than 1% of the pot, which is more reasonable for us to look at a solution and take some insights away from that solution. Finally, we are going to, let me move my picture over here. Oops, that's not the picture that I wanted to move. Let me move my face. So finally here on the top, on the right, let's go through the right side of the screen, and we can just walk through this last part of this post-flop tree building window. This is our accuracy settings section. The right side of our screen gives us some options about the accuracy. As I covered in Module 1, the solvers work by taking somewhat of an iterative approach, and the algorithm continuously exploits other players back and forth, each time both in position and out of position strategies moving closer towards an equilibrium. The solvers today we have aren't powerful enough to completely solve most scenarios, and especially again as we move further away from the river, there's an incredible amount of complexity to that entire game tree. So what we would typically do is set a stop point to say that the calculation is good enough. You'll notice here that there are a few options that we have. One, we can look at things in terms of percent of the pot, which is what I tend to recommend to do. There's also an option we can click here to stop it when we get to an exploitability of a certain BB per 100. Well, I tend to think that 1% of the pot is fairly good enough. As I've mentioned in the first module, we're already assuming a bit of error anyways with our fallibility of entering ranges, some of the kind of simplifications we're making in the model building process. So 1% error is not necessarily a huge amount. We may ultimately want to go a little bit more precise than that, or a little less precise than that if we want. But for really complex trees that might take a super long time, I might push stop a little bit earlier, or I might be okay with 2%. It's generally not necessarily an issue, but it can come up, especially when you're looking at deep or complex spots. We can also just stop it after a certain amount of time. So suppose we want to run it, especially if we want to run it up to 1% of the pot, but if it's going to take more than 10 minutes or 20 minutes or 30 minutes, we can add that time here in seconds, and the solver will run until one of those conditions is met, until it reaches that certain percentage of the pot, or it reaches that time limit here. And finally, this right window here, if we run a solve, what it's going to do is, this is kind of the log that we have here, and it's going to display some textual details around the iterations of the solvers. So it's going to include, both from each iteration, the EV of the out of position player, the EV of the in position player, but then it's going to also calculate for each one of those strategies what's the other player's maximum exploitable strategy against that, and how exploitable each player is by comparing the equilibrium value to the amount it could be exploited for by the other player's max exploit strategy. So this is the value it's trying to look at to optimize and compare to the overall percentage of the pot. When this exploitable for value is less than the accuracy that we set, it's going to stop, and that's going to be the accuracy that we ultimately set. And sometimes this right side screen can get a little full, and if we want to just clear the screen out, we could just hit clear logs, and what we're going to do here is it's going to ultimately clear this side of the screen. That was a lot. I know we just spent a lot of time going through all of the various options in this post-flop tree building and calculations window. In the next video, I'm going to shift over to look at the outputs. So, we do all of the stuff here to build a tree and set up a tree and ultimately run the tree. But we want to now look at the outputs of the tree, which we're going to do so from looking at the browser window. So stick with me in the next video and we'll cover the browser tab.